Now I'm going to tell you something that mathematicians don't want to hear. So listen, math is simple. It's very visual. And unless you have an image in your mind, you have not understood it. You don't have to be symbolically advanced to grasp advanced concepts. Your advanced symbolism is not going to help you to grasp advanced concepts. It's merely the way math is described today. Now tell that to a mathematician and he's going to be puking up his lunch all of a sudden and choking on it. Because as a mathematician, he's been taught to understand the way certain symbols work and then use those symbols to his own advantage to calculate what he wants. Of course, that's what you do. You use symbols. But instead of understanding how the symbols work, I say understand the meaning behind it. Understand how the objects work that the symbols describe. In plain English, use images instead of abstractions. Regardless, what I'm going to tell you first are the abstractions. And then you can connect the images to the known abstractions. First we define stuff, then we understand it.
As it turns out, co stands for complementi, which is just Latin for complementing. Now, what does it complement? Why? To what? That will only come to light when we understand the complex numbers. But there's another type of function that I like to tell you about, and that's the inverse trigonometric functions. These allow you to calculate the angle from the known lengths. The previous one, the normal trigonometric function, allowed you to calculate the lengths with a known angle, because the angle had a known ratio connected to it. These inverse functions are called arcus. For example, arcus sine. And seeing these here will tell you how to use them. But why is it called arcus? And also, what does this all have to do with waves? Because you know that the sine and the cosine are wave-like functions. They look like waves. If you look at the plot, you see that these hit the zero at pi or pi over 2 or 2 pi, 3 pi over 2. What is that? That sounds like a circle. The circumference of the circle is usually measured in pi's, because circumference is 2 pi r, as we know, given that the radius is 1, and that's just a logical thing to do. But now we're going to start looking at the cycle in more depth. And now we get to the radian, which is the most fundamental concept here. It's required to understand everything that comes after. So let's take a circle whose radius is 1. We call that the unit cycle or unit circle. The unit circle is when r is equal to 1. Now we do that because we set that as the basic measurement. Now in that circle, the radius of the circle is going to be 2 pi. Why? Because c is equal to 2 pi r. And if you take r, that is 1, you bend that radius and you put it onto the outside of the cycle. What happens is you get 1 over 2 pi of the cycle, that part. That is what we're going to call 1 radian. It's the radius bent onto the circumference. That's 1 radian. 2 pi radian, therefore, is the whole circle. Pi radian is half a circle. 90 degrees will be pi over 2, etc. Consequently, the radian is a measure of an angle. The reason why we use unit cycle is that length does not even come into play. Any angle can be measured in radian, so angles and triangles. And we'll see the angle in the wave. You can very easily and very intuitively tell where you are all you have to do is pick a 0 point.